The fact that enormous heavenly bodies exist, and the fact that we are also floating in the vastness of this universe is just a mind-boggling concept to wrap our heads around. Some say we are created by a powerful entity. Theories say we descended from apes, and some scientists think we came from stars.
We're going to talk a little bit about how each of us is actually made from dead stars.
Well, stars? Sounds new on our list, right? Stars not only twinkle in the night sky, they could also hold the key to the truth of our existence. So be sure to listen, because your eyes might sparkle from deep amazement. The birth of a star. Ever wonder what you would look like if you were a star? Not to be confused with the life of a starlet. Just kidding. I mean, if anatomy provides an in-depth study of human physiology, then take this as the astronomy class that would provide you with an in-depth understanding of the stars. Twinkle, twinkle, little star, how I wonder what you are. So, to answer this famous nursery rhyme, we should begin first and foremost by knowing the origin of a star. Scientists widely believe that the first star was born when the universe was just about 100 million years old. Some experts have also claimed that it was formed even earlier. But rather than settling that argument, let's just focus on how stars originate. We need to start with the table of elements, so even if some of you hate chemistry, just grab your copy of the periodic table. Looking at the entire table might be a little overwhelming, but luckily we just need to focus on hydrogen and helium. From these basic components, the life of a star begins. Let's welcome the first star that was ever formed. It's called the Population 3 star. To introduce this star effectively, it's necessary to take a deep dive into its formation process. The formation process of a star. Aside from knowing the basic components of the stars, it's also worth noting how these elements formed. Space doesn't have only one child, it contains various celestial bodies populated by their own matter. In the case of stars, they herald in the region of huge clouds, or what they call nebulae. Nebulae are made of dust and gas. These particles are so heavy that their own gravitational pull causes them to collapse. As it starts to collapse, the pressure inside increases. The center of the cloud becomes hotter and denser in the sense that the particles in that cloud start to meet and stick together. After that, it will reach a point where nuclear fusion begins.
Star is basically a nuclear furnace.
Fusion is the process that powers the stars. It occurs when hydrogen atoms collide to release another element in the process. So it's all thanks to hydrogen. For a short trivia note, did you know that scientists believe that hydrogen was the first element in our universe? Makes sense that it's the first element in the periodic table. Aside from its electronic configuration, there is also this reason. In short, hydrogen atoms are the foundation of the life of a star. Now that you know what fusion is, we can now welcome the other element in the group, which is helium. Helium is the first element that is created by the fusion of hydrogen atoms. After that, these elements will generate more energy, and ta-da! We now have a star. So, with this knowledge about chemical reactions, you can now have an answer to your kids' questions. In case they ask what makes the stars shine, just tell them that hydrogen atoms are the power that sparks the stellar revolution. Speaking of revolution and creation, of course, let's also talk about what comes next, the life of a star. Our class hasn't ended yet, so let's get to know how stars live, shall we? How do stars live? For all the astrophiles or lovers of stars out there, this is the question you've been waiting for. When we look at the night sky, we often search for a star to wish upon. Sometimes wishes do come true, but did you know they have their own problems too? Stars are living in the infinite blazing fires that they could only escape due to their exhaustion. Sad to say that in those moments that we admire their shining quality, stars are actually in a state of fiery turmoil. The qualities of the stars are the basis of their life, their longevity, and what happens to them after they die depend on their individual characteristics. So, what are these characteristics? The relative mass of stars determines their classification. The first classification is the surface temperature, called a spectral class. There are 7 spectral classes of stars, and they are classified by letters. M is the coolest, whereas O is considered the hottest. When it comes to its color, perhaps your favorite crayon is yellow whenever you shade stars, but did you know that you should color it blue this time? This is because blue stars are considered the hottest stars. Other hot colors are also red, yellow, and white. And speaking of colors, of course, they are also classified by the amount of light they emit, otherwise known as luminosity. This luminosity class has 9 major groups. They range from the smallest, which is called the white dwarf, to the biggest ones, which are called hypergiants. Now that we know their classifications, let's focus on one thing that truly matters, and that is the size of it. What drives the stars to grow in the first place? Well, of course, it's a matter of how heavy the elements created by the fusion. As stars age, they begin to create all sorts of elements that are heavier than hydrogen and helium. As a result, the outer layers of the star will begin to expand. It will eventually be hotter and bigger in size. Using the size of the stars, we can now also classify what they will become after they die. So I guess we're near the end. The conclusion clears the confusion about the death of a star. The death of a star. The idea that human beings are made from stardust isn't just a rumor. It will eventually make sense to you once you know how stars die. So, to continue where we left off about the size of stars, let's just use our planet Earth as an example. Imagine that the size of the star is just the size of our world. What would happen if it died? This kind of measurement is what they call a white dwarf. A white dwarf is the remnant of the small stars that die. But the question remains, how do stars die? Just so you know, our planet isn't the only one that has a core. Stars have cores too. It's where the elements fuse and make more energy. However, above all reactions that take place in this core, there will be a time that activities like this will no longer take place. This is because the chemical foundation of the star, which is hydrogen, will burn through its own fuel and die out. Prior to this, the lack of hydrogen to burn will cause the stars to die in numerous ways.
We have white dwarfs, neutron stars, and black holes that are just like weird in so many amazing ways.
One example is through explosions. This phenomenon is often referred to as a supernova. It is powerful enough to outshine all of a galaxy's combined light. One possible remnant of a star is the white dwarf, which we mentioned earlier. Its core will be left with no nuclear fusion. This white dwarf is very hot since it came from an explosion. But after some time, it will gradually cool down, and it will turn into a black dwarf. We know what will happen to small ones, but what about the medium-sized stars? The larger the star is, the heavier the elements that are present in its core. It will be able to fuse elements up to iron, and that is the limit. This signifies that there is an exhaustion of energy, causing it to collapse. And from this explosion, all that is left is its core, or what they call the neutron star. Now we are down to the last one, which is the largest star. To get straight to the point, stars that are much larger than our sun will create a black hole. They are massive enough that instead of leaving their core as the remnant, they will just collapse from their own core, and from this it develops a black hole, a gravitational well with no end. Given these various explanations, what, therefore, is the primary cause of humans emerging from stars? Well, not literally emerging, but the idea came from the very core of stars. We all know now that elements were formed in the cores of stars. Besides, it's widely believed by scientists that hydrogen and helium were the only elements that were present after the Big Bang. So generally, the core of the star is a living machine that creates other elements. And elements create things, not only things, but also human beings.
Yeah, that's right. Everything around you, including you and me, was formed from the remnants of exploded stars and the birth of the universe.
Knowing the scientific reason behind all scenarios is the living hope to quench our curiosity. By studying stars, we come to know that it does not only scope the life of the star itself, instead, it entails all various celestial objects like the elements, black dwarf, nebula, black hole, and even humankind. What do you think? Do you still support other concepts of science and tales? Or perhaps you were convinced by the idea that we Earthlings came from stars? Let us know in the comments below, and keep on shining.